We tend to think of science as this modern thing, like something that only exists now. But really, science is thousands of years old. So let's learn some history of science. Ancient Greek and Roman philosophers laid the groundwork for scientific thought by valuing reason and observation over myths and religious beliefs. But most of their work was more philosophy than science, because they didn't use the scientific method. But one notable exception was Greek astronomer Ptolemy, who figured out how to measure Earth's circumference by measuring the angle of a star at S altitude when it's directly overhead, and then finding another star whose altitude is 70 degrees. He assumed the Earth was a circle and used the basic math of the day to calculate the numbers. His estimate of the Earth's circumference was about 250 miles smaller than our modern value, but not too bad considering he did it around 150 AD. Chinese astronomers also made significant strides in understanding the universe. As early as 140 BC, they created an accurate model of the solar system and even identified the first 3 moons of Jupiter. Meanwhile, Arab scholars preserved ancient Greek texts and built on them. During the Islamic Golden Age, they made advancements in mathematics and astronomy and were among the first to use the scientific method. They correctly calculated the length of a year, measured Earth's circumference, and developed tools like the astrolabe to navigate by the stars. But the scientific revolution didn't fully emerge until Europe came along. It started in the 16th century with a focus on observation and mathematical precision. Nicolaus Copernicus proposed a heliocentric model of the solar system, placing the Sun at the center instead of the Earth. This contradicted the prevailing geocentric view, but was supported by observations from astronomers like Aristarchus, who estimated the size of the Moon and the distance between the Sun and Earth. Tycho Brahe made precise astronomical observations, including the first recorded observation of a supernova. These observations were collected and analyzed by Johannes Kepler, who formulated his laws of planetary motion, describing the elliptical shape of orbits and how planets move faster when closer to the Sun. Meanwhile, Galileo Galilei improved the telescope and used it to make groundbreaking discoveries like craters on the Moon, the phases of Venus, and 4 of Jupiter's moons. His support for heliocentrism led to conflict with the Church, highlighting the tension between science and religion during this period. Isaac Newton synthesized many scientific ideas, including gravity and motion, in his book Philosophiae Naturalis Principia Mathematica, laying the foundation for classical mechanics. He also developed calculus and made contributions to optics and other fields. His work shaped the course of science, emphasizing the importance of mathematical principles in understanding the natural world. The scientific revolution transformed the way we understand the world, shifting from a geocentric to a heliocentric view and emphasizing observation and mathematics in studying nature. It laid the foundation for modern science and continues to influence scientific inquiry today. The scientific revolution also sparked an increasing interconnectedness of the world as global exploration increased and knowledge spread across continents. The transatlantic exchange of goods, people, and ideas helped fuel the growth of science in both Europe and America. But what was life like for scientists back then? Well, there was no such thing as a scientist back then. Those doing scientific work were usually called natural philosophers, or just philosophers. And being a philosopher wasn't very well regarded at the time. It was seen as a dilettante pursuit, something that wealthy men did because they had nothing better to do. Not only were philosophers viewed as outsiders to mainstream society, but they often faced skepticism from those in positions of power due to their heretical views and discoveries. For example, Galileo Galilei spent the last 9 years of his life under house arrest after being convicted by the Catholic Church for supporting heliocentrism. His case remains a prominent example of the tension between scientific progress and religious orthodoxy. Another interesting aspect of early science was that it was extremely collaborative. Scientists would often work together, sharing ideas and data. This is in stark contrast to the modern trend of individual scientists working alone to publish papers and secure funding. There was no formal system of peer review, but scientists would share their work with colleagues for feedback. Before presenting it at scientific gatherings like the Royal Society in London, this collaborative spirit contributed to rapid scientific progress during this period. Despite these challenges, the scientific revolution marked a significant shift in human understanding of the natural world, laying the foundation for modern science and shaping our view of the universe. The emphasis on observation, experimentation, and mathematical analysis became central to scientific inquiry and continues to influence scientific thinking today. The works of Copernicus, Kepler, Galileo, and Newton, along with others, transformed our understanding of astronomy, physics, and mathematics and set the stage for future scientific advancements. The Enlightenment was a philosophical movement that emphasized reason, individualism, and human progress. It originated in Europe in the 18th century and had a profound impact on various aspects of society, including science, politics, and culture. The Enlightenment challenged traditional ways of thinking and encouraged a critical examination of long-held beliefs and institutions. Key figures like John Locke and Jean-Jacques Rousseau explored concepts like natural rights and the social contract, influencing political thought and the American and French revolutions. Thinkers like Isaac Newton and Albertus Magnus applied reason and empirical observation to scientific inquiry, laying the foundation for modern scientific methods. The Industrial Revolution was a profound transformation in the production process that began in Great Britain in the late 18th century and spread to other parts of Europe and the United States. It was characterized by the transition from hand production methods to machine production, leading to mass production, economic growth and urbanization. Key inventions like the steam engine, spinning jenny, and power loom mechanized tasks, increasing efficiency and output. The Industrial Revolution had far-reaching impacts, transforming societies, economies, and living conditions. During this time, new theories about how the body works emerged, challenging long-held beliefs and providing insights into human physiology. One notable development was the discovery of the circulation of blood by William Harvey in 1628. This groundbreaking finding overturned the prevailing Galenic theory and established the heart's role as a pump, circulating blood throughout the body. Harvey's meticulous observations and experiments laid the foundation for modern understanding of cardiovascular system. In the field of anatomy, Andreas Vesalius revolutionized the study of human structure with his book De Humani Corporis Fabrica in 1543. Vesalius accurately described and illustrated the complexity of the human body, correcting errors in earlier anatomical texts and emphasizing the importance of direct observation. His detailed dissections and anatomical illustrations remain influential in the field. Meanwhile, advancements in microscopy revealed the previously unseen world of cells and microorganisms.